Hi guys, let's look at the next question. The next question is question number 10. It says a cylindrical tank of diameter 2.8 meter and height 4.2 meter is being fed by a pipe of diameter 7 centimeter through which water flows at the rate of 4 meter per second. So this is in meter, this is in centimeter, again speed is in meter. So we need to do some conversions. Calculate in minutes the time it takes to fill the tank. So first we'll need to figure out how much volume we need to fill. So for cylinder, let's find the radius. Radius is equal to R is equal to 2.8 upon 2, which is equal to 1.4 meter. Next, height is equal to 4.2 meter. So volume to be filled, because we need to fill the cylindrical tank, is equal to pi r square h, which is equal to 22 upon 7 into r, which is 1.4 into 1.4 into 4.2 meter cube. 7 into 1, 7 into 0.2. I'll not multiply, but I'll just convert 22 into 2, that's 44, which means 4.4 into 1.4 into 4.2 meter cube. So we need to fill this much volume in the tank. Let's see what's the volume being filled in 1 second. So it says volume being filled in 1 second is equal to the length of 4 meters. So first we'll figure out the volume being filled in 1 second. And the pipe. So let's look at pipe first. So for pipe, point number 4, radius, let's write it as small r, is equal to 7 upon 2 centimeter. So point number 5, volume being filled in 1 second will be equal to area of cross section of pipe multiplied with length. In this case the length is 4 meter, right? And since this is given in meter, we need to convert this into meter. So this would be 7 upon 200 meter. Let's reconfirm. Yes, that will be 7 upon 200 meter. So area of cross section of the pipe, which is a circular pipe, would be pi r square. So this would be 22 upon 7 into r, that's 7 upon 200, 7 upon 200 into length. So this is pi r square multiplied with length. Length is 4 meter. So this is volume being filled is in meter cube. So 7 and 7 gets cancelled. This is 2 into 1, 2 into 100. Sorry, 2 into 2, 2 into 100, 2 into 1, 2 into 100. I'm leaving this with the in the denominators 100 or rather 10 to the power something, so that it's easier to convert when I need to divide. So this will be 1 with 4 zeros. Let's confirm. 22 into 7, which is 154 upon 1 with 4 zeros. That's fine. 10,000 meter cube. So this volume comes out in 1 second. This volume will come out in how many seconds? That's the question. Correct? So 22 into 7 upon 10,000 is the volume coming out in 1 second. This is the volume we need to fill. It's basic unitary method. So 22 into 7 upon 10,000 is meter cube is filled in 1 second. Therefore, just draw a line here, demark it. Perfect. Therefore, 4.4 into 1.4 into 4.2 meter cube gets filled in. That's unitary method. So 4.4 into 1.4 into 4.2 multiplied with 1 upon divided by this. So this is multiplied with 10,000 upon 22 into 7. Right, this is correct. Let's now divide. This is 20 to 1 and 22 into 0.2. This is 7 into 1, 7 into 0.2. So this is 2 into 2, 4, 4 into 42. That 42 into 4 would be 168. Yes, so that's 168. And how many decimals? 1, 2, 3. So this is 0.168 multiplied with 10 with 1 with 4 zeros seconds. 4 zeros, which means this will be 1680 second, which would be equal to 1680 upon 60 minutes. That's 6 into 1, 2 into 6 into 2, 12. That's 48. So 28 minutes. So 28 minutes it will get filled in. This is basically unitary method. It required one volume to be filled. Second, it required volume being filled in 1 second using the formula area of cross section into length, and then it required basic unitary method. Let's look at the next question. The next question that we do is question number 11. It says water flows at 9 km per hour through a cylindrical pipe of cross sectional area 25 square centimeter. If this water is collected into a rectangular cistern of some dimensions, calculate the rise in level in 1 hour 15 minutes. So again, a similar question like the last one. We need to calculate volume coming out of the pipe. Since this is given in kilometer per hour, let's convert this into meter. So point number 1, length would be equal to 9 kilometer, which is equal to 9,000 meter. Next, volume of water in 1 hour, since this is given as per hour, will be equal to area of cross section multiplied with the length. Now area of cross section is given in square centimeter. This we've converted into meter, so we'll have to convert this into square meter as well. That will be 25 upon 1 with 4 zeros multiplied with length, which is 9,000 meter cube. I hope you understand this is square centimeter. This we have taken in meter because the final answer is required in meter. So that's why I've converted this into meter. This also into square meter. So now let's see what do we get. These two zeros gets cancelled. This 0 gets cancelled. So what we have is 25 into 9, which is only 1 0 remains. That's my mistake. Yeah, 1 0 remains. Oh, let's just reconfirm. These two zeros get cancelled. This 1 0 and this 1 0 gets cancelled. So now what we have is 5 into 5, 5 into 2. So this is 45 upon 2 meter cube. Let's just reconfirm. 25 upon 100 into 100 into 9,000. 3 zeros get cancelled. I still have 1 0 in the denominator. So that's 45 upon 2 meter cube. Now let's apply unitary method because they want it in 1 hour 15 minutes. So in 60 minutes, water flows is 45 by 2 meter cube. Therefore, in 75 minutes, water flows out will be 75 into 45 upon 2 multiplied with 1 upon 60. Perfect. Let's divide by 60. 15 into 3, 15 into 4. And what we have, so this is in meter cube. So this would be equal to, let me just draw a line to demark it. Okay. So what we'll have is 75 into 3, that's 210, 225 upon 8 meter cube. So this is the volume which will flow out in 1 hour 15 minutes. Now again, this time we have a rectangular system. We've been doing such questions for cylinder. Let's look at this question for a rectangular system. Let's look at the cross section. I'll not draw the full thing. So let's say the this is the increase in height due to the water flowing out in 1 hour. So this volume, which is this shape, which is basically a mini rectangular cistern, which means mini cuboid, the volume of this is 225 by 8. So let rise in level be h meter. Volume of a cistern is given by volume of mini cistern, we're calling it a mini cistern, would be equal to 225 by 8. Volume of a cuboid is given by length into breadth into height. So length is 7.5, breadth is 5, and height is h. Now we need to calculate h, which means h would be equal to 225 upon 8 multiplied with 1 upon 5 multiplied with 1 upon 7.5. Right, so that's 5 into 4, 20, that's 45. 5 into 9, that's 5 into 1.5, 1.5 into 1, 1.5 into 6, 2 into 3, 2 into 4. Therefore, height is equal to 3 by 4 meter is equal to 0.75 meter is equal to 75 centimeter. That's it. Good. Let's look at the next question. The next question that we do is question number 15. Question number 15 says an exhibition tent is in the form of cylinder surmounted by cone. Height of the tent above the ground is 85 meter and height of the cylindrical part is 50. So this height is 50 and the total height is 85, which means the height of the conical part is 35. The diameter of the base is 168, which means the radius is 84. Let's just write for cone, height is equal to h is equal to 85 minus 50 is equal to 35 meter. Radius is equal to r is equal to 168 upon 2, which is 84 meter. And for the cylinder we have height, let's take it to be small h, is equal to 50 meter, and radius, which is the same for both of them, is equal to capital R is equal to 84 meter. What do we need to do? We need to find quantity of canvas required, which means we are basically looking at the total surface area. So total surface area of tent would be equal to curved surface area of cylinder plus curved surface area of cone. So for the curved surface area of cone, I need to know the slant height. So let's just calculate the slant height. So if I use the Pythagoras theorem, I'll have to do square of 35, square of 84. Let me see if there is anything common between these two. Yes, this can be written as 7 into 5. So this is 7 into 5 and this is 7 into 12, which means this is 7x, this is 5x and this is 12x, where x is 7, 5, 12 and 13 is a Pythagorean triplet, which means this side will be 13x, which is 13 into 7, that's 91. In case you did not understand this, you could do the Pythagoras theorem and this side will be equal to the square root of 35 square plus 84 square. If you do this, you will still get the answer as 91. Let me just quickly revise what I did. I looked at this length as I looked at 35 as 5 into 7. So this I looked at 7 into 5. This was 7 into 12. 7 is the common factor, which means that's the x. So this is 5x, this is 12x, which means this is a 5x, 12x and a 13x Pythagorean triplet. 5, 12 and 13 form a Pythagorean triplet, which means this side is 13x, which is 91. So slant height is equal to L is equal to 91 meter, since 5x, 12x and 13x are Pythagorean triplets. This kind of a trick will save you time in your examination, so you should understand how to get into this Pythagorean triplets and remember these Pythagorean triplets. So total surface area would be equal to curved surface area of cylinder, which is 2 pi r h small h plus pi capital R L. Anything common, pi r I can take common, so that's 22 upon 7 into r, which is 84, multiplied with 2h. 2h is 2 into 50, that's 100, plus L, which is 91, that's meter square. So total surface area would be equal to, that's 7 into 1, 7 into 12. So this is 22 into 12 into 100 plus 91, that's 191 meter square. Now we'll have to do a long calculation. 191 into 12, 2, 9 into 18, 3. That's 191. This is 2, 9, 9 plus 3, 12. That's 2292. Next, 2292 multiplied with 22. That's 4, 9 into 2, 18. 4 plus 1, 5, 4. So this is 4, 8, 5, 4 here as well. This is 4, 8 plus 4, 12. 13 plus 1, 14. 10. That's 50424. This is 50,424 meter square. Now the last part of the question, which talks about in case there is a wastage. These kind of questions are not a part of your syllabus, but let's still look at this question. It says allow 20% extra for stitching and folds, which means total canvas required would be equal to 50,424 plus 20% of 50,424. So that calculation you can do. The answer you will get would be 60,508.8 meter square. The question says calculate it to the nearest square meter, which means this would be 60,509 meter square. Wonderful. That brings me to the last question of this exercise. Let's look at that question. It says a conical tent is to accommodate 77 people. Each person must have 16 cubic meter of air to breathe. Okay. Given the radius of the tent is 7 meter, find the height of the tent and also the curved surface area. So first unitary method, one person needs 16 meter cube of air. Therefore, 77 people will need 77 into 16 meter cube of air, which means volume of tent should be equal to 77 into 16 meter cube. Volume of tent we know is 1 by 3 pi r square h. This should be equal to 77 into 16. Well, let's substitute values. 1 by 3 into 22 upon 7 into r, that's 7 into 7 into h, is equal to 77 into 16. As 7 and 7 gets cancelled, which means h is equal to 77 into 16 multiplied with 3 divided by 77 gone, 16 gone, 3 gone. In the denominator, I have 22 into 7. 7 into 1, 7 into 11, 11 into 1, 11 into 2, 2 into 1, 2 into 8. Therefore, h is equal to 24 meter. So the height of the tent is 24 meter. Next part of the question, curved surface area. Now we know curved surface area is pi RL. For that we'll need to know the slant height. So slant height would be equal to L, will be 24, 7 and 25 are Pythagorean triplet, is equal to 25 meter. Therefore, curved surface area is equal to pi RL, which is 22 by 7 into 7 multiplied with 25 meter square. 7 and 7 gets cancelled, then 25 into 22, which is 550. So 550 meter square. So the curved surface area is 550 meter square. That finishes this video for me and also the whole chapter. In case you have any doubts or queries, feel free to get in touch with me. Thank you so much. Take care. Be safe. Bye-bye.